Alright, so here we go with our first video on the review material. First thing is to sketch the graph and state the domain and range. So we know that our basic square root graph starts at the origin, increases to the right. So just as a reminder, square root of x minus 1 would move the graph over 1 to the right, plus 3 would move up 3, and I would still have the same shape. My domain would start at 1 and go to infinity. Remember interval notation. And my range would start at 3 and go to infinity. And that's how I would write domain and range for the problem. Next, cube root. Our basic cube root sketch. Increases to the right, decreases to the left. So again, if I want to sketch this, x plus 2 would move me left 2. Minus 1, so now the center would be at negative 2, negative 1. Same basic shape. Because it goes in both directions, both the domain and range are negative infinity to infinity. Next we have our quadratics. So first, if it's in HK form, pretty simple. I have x minus 3, so I'm going to move to the right 3. Plus 2, up 2, it opens up. And we're just talking basic sketches here without your calculator. Domain of quadratics is all real. And my range is either going to be greater than your vertex or less than your vertex. So here it will be greater than. So it will be 2 to infinity. Now, what if I have a quadratic that's not in HK form? A couple of things you can do. You can make a table, plug the values in, or can say, wait, I remember that I can just factor this, take an x out to get the zeros. So the x-intercepts would be 0 and 2. So my vertex would then be between those two at 1. So then I could plug 1 in to figure out the y value of the vertex. So if I go and plug 1 in, I have 1 squared minus 2. 1 minus 2 is negative 1, and it opens up. Again, my domain is negative infinity to infinity, and my range will be greater than the vertex. The y value of the vertex is negative 1, so I will go negative 1 to infinity. Next we have exponential. Our basic exponential curve, quick reminder, crosses the y-axis at 1 and increases left to right. So 2 to the x, and that's all I really need to do. 2 to the x crosses at 1, because anything to the 0 power is 1, and it's going to increase. Now remember, e to the x is just like 2 to the x, because it's 2.71, plus 3 would move it up 3. So instead of crossing at 1, it would cross at 4, and it still would increase left to right. Domain and range would both, the domain would be all reals. And now my range, if I think back to my first graph, my range is going to be everything above the x-axis. So now my range is going to be everything above 3. So I'm going to go 3 to infinity for my range. I'm not going to include 3 because that's actually going to be my asymptote there. So next we have our logarithmic graph. First we want to change this to exponential form. Remember, it's 2 to the y equals x. So this really turns into 2 to the y equals x, which then, if I plug 0 in for y, I get 1 for x. So I have an x-intercept, and it increases left to right. If the base is greater than 1, and it's going to decrease, it would look like that if the base was less than 1. Next, natural log of x. The only thing we have to remember is that the base is e, so this turns into e to the y equals x. Again, which e is 2.7, so it looks very similar, and it's just increasing a little faster than 2 to the y equals x. Next type of graph, we have our rational graphs. So first I just have the most basic 1 over x, which has an x-intercept which has a x-axis is the asymptote and the y-axis is my asymptote. And my branches are going to be top left, top right, and bottom left. If it looked a little more complicated, now my x equals -3 would be my vertical asymptote, x plus 3, and +2 would be my horizontal. And again, the branches would still be top right and bottom left because it's positive. In order to switch, I would need a negative sign. Last one on this page is absolute value. We remember it's the shape of a V. So I would do x minus 3 over 3 plus 1 up 1. There's my vertex. And the 2 is actually, I'm going to go up 2 and over 1 on both sides to get my V. If it were negative, the leading number, it would open down. Okay, now we need to find the restricted domain and interval notation of each. So I have in the top right hand corner to remember, you need to remember two things. Denominator cannot equal 0, and if I had a square root function, the radicand, fancy word for what's underneath the radical, has to be positive, greater than 0. So my first problem, I have a denominator that cannot equal 0, so I'm going to actually set it equal to 0 and solve. I can factor, or you can just add the 4. I'm going to factor x minus 2, x plus 2 equals 0. So x cannot be plus or minus 2. Now interval notation would say I'm going to go from negative infinity to negative 2, or negative 2 to 2, or 2 to infinity. There's my interval notation for x cannot be plus or minus 2. Second one, the radicand, which would be 3x minus 4, must be greater than or equal to 0. And I just solved this simple inequality to get x is greater than or equal to 4/3. Interval notation would be 4/3 to infinity, including the 4/3. Okay. Now I have determine if the following are even, odd, or neither. Favorite kind of problem. So I have over here, you need to find f of negative x. When you find that, you're just plugging negative x in for x to see what's happening when x is the opposite sign. This would still be negative with the algebra, and this would turn plus. If you recall, if all of the signs have changed, which they have, negative x squared, x cubed plus 4x, it's odd. If I get the exact opposite, if it's the exact same thing, then it's actually an even function. Okay? And down here I have the symmetry of each one. So remember, even functions are symmetric over the y-axis. Your most basic example is x squared. And odd are symmetric over the origin. Your most basic is x cubed. And I'll write underneath, for even, f of negative x is going to be f of x, the exact same thing. For odd, f of negative x is going to be negative f of x. Just means all the signs will change. Okay. Now we have find the inverse of each function. Remember, inverse just means the x and the y's have switched. So the domain of one becomes the range of the other. So to find it, you're literally just going to switch. Switch your x's and y's. So this would become y equals 2x minus 1. So when I switch, it's going to become x equals 2y minus 1. And now I just need to solve for y. So I would have x plus 1 divided by 2, doing the algebra quickly, equals y. And I need to remember the inverse symbol. Now what if it's a little more complicated? So I would switch and I would say x equals 3y plus 1 over y minus 2. Now how do you solve this for y? First thing I'm going to do is multiply both sides by y minus 2. So I'd get x times y minus 2 equals 3y plus 1. Now I'm actually going to distribute xy minus 2x equals 3y plus 1. Now I have two terms that have y in it. I'm going to collect those two terms. So I'd have xy minus 3y, and I'd move the 2x to the other side, so I'd have 2x plus 1. Now I can factor the y out, so I'd have x minus 3, 2x plus 1, and just divide by the x minus 3, so I get y inverse equals 2x plus 1 over x minus 3. Okay, last piece of information, one-to-one functions. I already have it written. Okay, f of x is one-to-one if both the original and the inverse are both functions. Graphically, it needs to pass the horizontal line test, the original. Next, the difference quotient. Probably don't remember it. Here is the difference quotient that we talked about last year. Just going to remind you, this is really just function notation. So the first thing I'm going to do is find f of a plus h. So I'm going to plug a plus h in for x. So I'd have a plus h squared minus 3. That's f of a plus h. Minus f of a. So now I'm just plugging a in for x. So I would have a squared minus 3. Remember, you're subtracting that entire thing, so you need parentheses, all over h. Now you just need to do some algebra. I'm not going to ever forget to FOIL. I have a plus h squared, so I'm FOILing that. A squared plus 2ah plus h squared minus 3, and I'm distributing, so it becomes, that is my numerator, and that's all over h. And now things will start to cancel for me. So a squared cancels, 3 cancels. I'm left with 2ah plus h squared over h. Factor the h out of the numerator. And the h cancels, and I'm just left with 2a plus h. Next, I have solving exponential and logarithmic equations. So the first one, 2 to the 3x minus 1 equals 5. I know that I cannot change 5 to base 2, so I need to use logs. I'm going to take log base 2 of both sides because 2 is the base. So we'll take log base 2 of both sides. The left side, actually, I can use my log properties, bring down the 3x minus 1. Log base 2 of 2 is just 1, so it kind of cancels, equals log base 2 of 5. Now, just your algebra, I can add 1. So, log base 2 of 5, quantity plus 1, and divide by 3. If I want to get a decimal value, you can do log base 2 of 5 on your calculator. If I ask for exact value, that would actually be my answer. Next problem, we need to use our log properties. Quickly remind you, addition, I combine two log terms with multiplication. So if I'm adding, I would actually combine these two by writing 5x. Subtraction is division. So the left side would become log base 2 of 5x. Now once I've combined them to one log, I can change it to exponential form, which is 2, to the third power. So 2 to the third power equals 5x. It's always the base to this power equals this quantity. And now just solve. 2 cubed is 8 equals 5x. So x would be 8/5. Last one here, guys, is a natural log problem. First, I want to get rid of that 5 by dividing. I want to isolate the log. So 15 divided by 5 is 3. Now just remember that natural log is base e. So once I know that, this really just becomes the same thing as before. So now I would change to exponential form, and I would have e cubed equals x plus 4 and solve for x. So my answer is x equals e to the third minus 4. Okay. And finally, we have, Last problem, trigonometric equation. Okay, I haven't said anything about the unit circle. I am considering that you have already filled out a unit circle. You'll spend some time doing that. So in order to solve your trig equations, guys, you need to know your unit circle, be able to do that without looking at one for the test. I will give you a blank one if needed. All right, so I have one trig function in this equation, so I want to isolate that. So the first step, I would divide by this 2. So I'd have sine of 2x equals 1/2. Now I'm going to say, when does sine equal 1/2? So I'd go to my unit circle and I'd figure out when does sine equal 1/2. So I'd be at pi over 6 or 5 pi over 6. So then I would just set 2x equal to those two values. So I would have 2x equals pi over 6 or 5 pi over 6. And then I would just divide by 2. So my answers would be pi over 12 or 5 pi over 12. There are many more trig equations that we have solved. More complicated where I have, let's say, a sine squared in the problem and a cosine squared in the problem. So what would you do? You would replace one of these using your Pythagorean trig identity. So if I wanted to change all of these to sines, I would change cosine squared to, hopefully you remember, sine squared plus cosine squared equals 1. So cosine squared would be 1 minus sine squared. And then I could solve the problem, which in here would be no solution because the sine squared would cancel. But I'm just showing you, reminding you, if you have both sine and cosine, I need to change one of them to the other. Other kind of problem you'll see is a factoring problem with, say, sine in the problem. Something like this equals 0. So it looks like a quadratic. Sine squared minus 3 sine plus 2 equals 0. I can factor, and instead of x and x, I'm going to use sine of x and sine of x, because sine times sine would be sine squared, and multiplies to 2, adds to negative 3 would be minus 2, minus 1. And now I can set each piece equal to 0 and solve. So the first would be sine equals 2, which is, there's no solution. And this would be sine equals 1, and then you would go to your unit circle to get your values when sine equals 1. All right, so hopefully that was a quick review of all of the things that you need the most review with, and anything else we will definitely go over.